Hi, this is Ma'am Clarence, and today we will learn Chapter 1, Lesson 1, which is Introduction to Limits. Today, our goal is to first illustrate the limit of a function using table of values and graph. Second, to distinguish between the limit of f of x as x approaches c and f of c. Before we proceed to the definition of limits, let us first understand what limits are. Take note that the idea of limit is fundamental to the study of calculus. The word limit suggests a boundary that may be either reached or not. A mathematical limit is analyzed by looking at how a function, value, or output changes when various inputs change. Now, mathematically, the definition of a limit says that if f of x becomes arbitrarily close to a unique number L as x approaches c from either side, then the limit of f of x as x approaches c is L. This is written as this symbol. Now we read this symbol as the limit of f of x as x approaches c is equal to L. We refer to this as the two-sided limit. It only exists if both one-sided limit exists and are the same. That is, f of x approaches the same value as x approaches the given value from both the left and the right side. Now, to understand this better, let us have here an example. Now, we could understand limits using table of values and graph. We will first discuss how to understand limits using table of values. Now, consider the function f given by f of x equals x plus 8. So our function here is f of x equals x plus 8. Suppose we choose a number x closer and closer to the number 3. Now, we can illustrate this using our table of values here. Now, this graph is for representation purposes so that you may see what we mean clearly. Now, take note, in this table of values, we choose a number here, the value of x's. We choose numbers which get closer and closer to 3. Now, if we choose numbers from the left of 3, okay, from the left side, meaning before 3, so for example, we have 2, 2.5, 2.9, 2.999, and so on. Now, we also have numbers from the right of 3, meaning these are numbers after 3. So we have 3.1, 3.5, 4, or we could also have other numbers from the right of 3. Now, take note, while looking at this table of values, as the numbers in x get closer and closer to 3, the numbers in f of x also get closer and closer to a certain value. This time, as the numbers in x get closer to 3, the numbers in f of x also get closer to 11. So, we can say that as x approaches 3 from the left, so from the left is symbolized by this negative sign above 3. So, the limit of x plus 8 as x approaches 3 from the left is 11. The same way that the limit of x plus 8, this is our equation, as x approaches 3 from the right, okay, so from the right is symbolized by this plus sign above 3, is also 11. Since both of the limits from left and from the right approach the same number, then we can say that the limit of the function x plus 8 as x approaches 3 is 11. This means that as the value of x gets closer to 3, the value of f of x or y gets closer to 11, either from the left or from the right side. Now, let's have some other examples. So for example, we're going to find the limit of 3x minus 2 as x approaches 2. Basically, the question here is, what number in y is being approached as values of x become closer to 2? So, we have here our table of values. Okay, so take note, the value of f of x here is in a question mark, still in a question mark, because that's what we're going to find out. Take note, we also have a graph here, but we will focus on understanding the limit using the graph later. For now, we will focus on getting the limit using this table of values. Now, let us examine the values of x. So, as the values of x become closer to 2, from left, okay, so we look at the numbers in f of x or in y. So this is 3.700, 3.970, 3.997. So what do you think is the number that it gets close to? Okay, so from the left, okay, the limit of 3x minus 2 as x approaches 2 from the left is the number 4. So as you can see, as the values of x become closer and closer to 2 from the left side, the value of f of x or y gets closer and closer to 4. Now, let's look at the values from the right. Now, we have here, as the values of x approaches 2 from the right, the values of f of x or y also get closer and closer to 2. So we say that the limit of 3 of x minus 2 as x approaches 2 from the right is also 4. Therefore, since the limit from the left and the limit from the right are the same, then we can say that the two-sided limit of 3x minus 2 as x approaches 2 is equal to 4. So this means that whatever value of x that you choose and it gets closer to 2, okay, the value of f of x or y will also get closer to 4. Next example, we will find the limit of 3x squared as x approaches negative 1. So again, we have here our table of values. Let's examine. As the values of x get closer to negative 1 from the left, the values of f of x get closer and closer to what value here? So that value is 3. So we say that the limit of 3x squared as x approaches negative 1 or as x gets closer to negative 1 from the left again. So we see here the negative sign above negative 1. That is 3. Then from the right, it also gets closer to 3. So take note, you can say that it is the limit from the right when you have here a plus sign above your c. So therefore, we say that the limit of 3x squared as x approaches negative 1 is 3. Okay, another example. We find the limit of x minus 4 over x squared minus 16 as x approaches 0. Okay, so we see this table. So in this table, as x approaches 0 from the left and from the right, it approaches 0.25 or 25 hundredths. Therefore, we can estimate the limit, okay, the limit of x minus 4 over x squared minus 16 as x approaches 0, that is 25 hundredths or 0.25. And another example, find the limit of x minus 4 over x squared minus 16 as x approaches 4. So we're given here a table. From the table, it appears that the closer x gets to both 4 from the left and from the right, the value of f of x becomes closer to 0.125 or 125 thousandths. So that's the same value from the left and from the right. Therefore, we can say that the limit of x minus 4 over x squared minus 16 as x approaches 4 is 125 thousandths or 0.125. Okay. Take note, however, that if you directly substitute 4 to the function x minus 4 over x squared minus 16, the calculator will display the word math error. Again, if you directly substitute 4 to this equation, the calculator will display the word math error. However, if we look at this table of values, the limit of the function as x approaches to 4 is 0.125 or 125 hundredths. Now, this would lead us to the conclusion that the limit of the function f of x as x approaches c and f of c, okay, that's directly substituting the value of c to your function, are not always equal. So the limit, the answer that you get in the limit, and the answer that you get when you substitute this number to your x's in the equation are not always equal. Now, let's move to understanding limits using graphs. Now, we have the example limit of negative x minus 2 as x approaches negative 1. So take note, we have the graph here. Okay, we have the graph here. So, let us look at the graph. Examine the graph and we will see what value of f of x is approached. Take note, as x approaches negative 1 from the left, okay, so this is from the left, this is negative 1. Okay, so we look at the values in the x-axis. This is negative 1. Okay, so take note, as we approach here, as we approach negative 1 here, this is negative 1. Okay, this is the part of the graph. What value of y is approached from the left and from the right? Okay. Okay, let's see what value of y is approached here. Now, take note, as the value of x approaches negative 1 from the left and from the right, the value of y that it approaches is negative 1. So we can say that the limit of negative x minus 2 as x approaches negative 1 from the left is negative 1. From the right, that's also negative 1. Therefore, the limit of negative x minus 2 as x approaches negative 1 is negative 1. Let's have another example. Now, let's find the limit of negative x minus 2 as x approaches negative 4. So, we're still using the same graph because this is still the same function. Again, x will approach negative 4. So this is, we look for negative 4 in the x-axis. So as x approaches negative 4. Okay. Okay, so this is negative 4. Let's see what value of y does it approach. Okay, so this is negative 4. Okay, as it approaches negative 4, what value of y is this? Okay, so it appears to be positive 2. Positive 2 from the left and from the right. So we say, as the value of x approaches negative 4, okay, the value from the left and from the right both approach positive 2. Therefore, the limit of negative x minus 2 as x approaches negative 4 is 2. Next, we have here, we're going to find the limit of negative x minus 2 as x approaches positive 1. Now, we look for positive 1 in the x-axis. So this is positive 1. Okay, so as x approaches positive 1 from the right and from the left, okay, what value does this approach? Okay, what value of y does this approach? So this is, okay, so the value that y approaches is negative 3, both from the left and from the right. So we say that the limit of negative x minus 2 as x approaches 1 is negative 3. And the last example, we have limit of negative x minus 2 as x approaches 0. Again, this is 0. We look for 0 in the x-axis. Okay, so this is 0. Okay. So from the left and from the right, what value of y does it approach as the value of x approaches 0? So from our graph, we see that as x approaches 0 from the left and from the right, y or f of x approaches negative 2. Therefore, the limit of negative x minus 2 as x approaches 0 is negative 2. Okay, so here, let's recap some important concepts that we learned today. So here are our observations about limits. First, the definition of limit implies the values of x of a certain function cannot approach two different limits at the same time. So, if you remember and if you've seen from our examples, the limit from the left and from the right both approach the same value of time. Okay, so if a limit exists, there will only be one limit when a certain value of x is being approached. Second, a limit may not always exist. Now again, take note, the limit will only exist if the limit from the left and from the right are equal and are the same. If the limit from the right is not equal to the limit from the left, then during that time, the limit will not exist. And lastly, the limit of f of x as x approaches c is not always equal to f of c. Okay, so the evidence of this is or was shown in our example number 4 in understanding limits using table of values. You get it? See you in the next lesson. Bye!